Hello friends, welcome back to my channel. Today we are going to solve a problem involving greatest integer function that is called the gf of something, this gf greatest integer function, also known as the float function. Now this question is from 1993 China National Mathematics Olympiad. This problem tells us that we have to find the last two digits of the number 10 to the power 93 over 10 to the power 31 plus 3. To people who are new to GIF, let me tell what GIF is. Suppose we have x as 9.6. The GIF of x will be 9. Similarly, what I mean to say in general, that if x plus 1, or in interval notation, if this is x to closed x plus 1, then GIF of a equals x. This is so like GIF of 10.8 would be 10. Even the GIF of 10.99999 and so on will also be 10. In case of negative numbers, GIF is defined to be the greatest integer less than or equal to x. So in case if it is 10.8, here the GIF would be minus 11, because 10 is plus in the, if I draw the number line. So to write this number in this interval notation, minus 10.8 lies between minus 11 to 10. So you can see why I wrote this 11 here. So this is the main idea behind this GIF function, and that's what that involves. So we can clearly see that this one is a, yeah, if I zoom this eraser, yeah, so let me erase this thing off. So this stuff here will always be an integer irrespective of what the uh, denominator is. So let's start. So I want you all to solve this question after you know what is GIF, what is greatest integer function. So pause this video and give this problem a try, and when you're done, keep watching the video for the solution. So for this question, we assume n to be equal to 10 to the power 31. So this makes our work easier. How? So indirectly we have to find the GIF of n to the power 3 by n plus 3. Now n, we can write this as, when n plus 3 divides n, the quotient we get is, you can do the long division, n square minus 3n plus 9. This is the thing we get on. Now if we write this, and the remainder we are left with is minus of 27. You can confirm this by doing long division. Let me do it for you. N cube n plus 3. So this goes n square times. So here we get 3n square minus 3n square. Again we do minus 3n. So we get minus 3n square as desired to cancel this thing, and we are left with minus 9n. this minus 9n turns to 9n. So we got to multiply by 9, 27. This cancel, these to cancel, these to cancel. Now we are left with minus 27. So that's what I said. Minus 27 is the remainder, as I said earlier, and n square minus 3n plus 9 is the quotient. Now if I put this thing over here, so if I assume this to be p, now p equals greatest integer function of g of n square plus 3n minus 3n plus 9 minus 27 over n plus 3. Now, since this is an integer and we have a property that n plus k in greatest integer function equals n plus j of k if n belongs to naturals, and then that's what we are going to do here. So this is obviously a natural number as n equals 10 to the power 31. So we can separate this as n square minus 3n plus 9 plus j of minus 27 over n plus 3, and this in turn equals p. So, and this is going to, this thing is some 0 point something, and so the j of that thing is minus 1. It is 10 to the power 62 if I resubstitute n, and this is 3 times 10 to the power 31. So this involves 31 zeros at the back. So the last two digits are 09 as desired. So the last two digits are 09 minus 1, so 08. Hence the last two digits of the number are 08. So this was the solution of the problem. Hope you enjoyed it. Stay tuned for more such